Okay, here we go. So today, 8-3, rational functions. Okay? Rational functions and their graphs. And we're going to spend 3 days on 8-3 because it's that much fun. So note that I want you to define rational functions on page 363 of your textbook. So think about a minute there. Get that definition down. We'll talk about it here. Rational functions, what are they? Nick?
A function that is a quotient of two polynomials.
Good. Function that is a quotient of two polynomials. So for instance, we have y equals a polynomial on top, say like x minus 3, and on bottom, y equals, or on the bottom, maybe x squared minus 2. Okay? That is potentially a rational function. Okay? That is a rational function. Okay? The quotient of two polynomials. Now, the ones that we have seen lately, like have a whole number on the top, that's also a rational function. Okay, it's just that the polynomial on top is really boring. Okay, it's just one. Okay? And sometimes you'll see it in textbooks, maybe written as f of x equals like g of x over h of x. That's just saying that this function is equal to this function over that function. Okay? Generally, our textbook I don't think goes into that. Does our book actually show that? No?
Yeah, it does.
Does it?
Is it h of x equals f of x over g of x?
Nice. It actually kind of does say that. That's cool. Okay. And we don't use that a lot. All right. Any questions there? Okay. What does it mean if a function is continuous? You can look on page 364. That may help you out there. Tell your neighbor what. All right, go ahead and tell me what it means before you write everything down. So what does it mean if the graph of a polynomial function is continuous? Sam?
It doesn't jump, break, or have holes.
Good. It doesn't jump, break, or have holes. So if you're graphing it, another way to think about it, if you're graphing it, you don't have to pick up your pencil. Well, after you've picked it up originally, right? So if I'm graphing this, there's my graph or my xy axis. If I'm graphing my rational functions like it was yesterday where I had this branch, and then I had this branch. Note that to go from this branch to this branch, I had to pick up my pencil. Right? I actually had to, physically, I can't draw this one and keep going and draw that one. I have to lift it up and come up here. That means this is discontinuous. It is not a continuous graph because I lifted my pencil when I was graphing. Everyone get that? Okay. Ask your neighbor, hey, you get that? Okay. So that means if a function is discontinuous, you do have to pick up your pencil to graph it. Okay, you must pick up your pencil to graph it. That's a graph that is discontinuous. Say like that graph right there, discontinuous because I had to pick up my pencil. So part of our goal today is recognizing continuous from discontinuous while you're graphing. Okay? Questions there? All right. That being said, I want you to take a look at these three graphs. Tell your neighbor, continuous or discontinuous. Ready, go. Okay, time's up. Number 3, everyone. Discontinuous. Number 4. Discontinuous. Number 5. Continuous. Now, how many discontinuities does this graph have? 3. Now, we call them discontinuities because that's where we'd have to pick up our pencil. So if I'm graphing this, I'd have to pick up my pencil. There's a discontinuity. Okay? If I'm graphing this one, I'd have to pick up the pencil again. There's a discontinuity. In fact, you would even have a horizontal one right there. Okay? So we're really counting the vertical ones. We have 1, 2 discontinuities there. Okay? And how many does this one have? Actually, it has 1. This has what's called a slant asymptote. Okay? It runs right like that or so. And we'll learn how to graph those here in the future. Okay? Any questions there? Okay. So, how do we find when a rational function is discontinuous? When is it? Yep. Good. Good. When the denominator is undefined. So if I was taking a look at a graph like that guy or an equation like this, we know what it looks like in picture form. In an equation form, we can tell something's discontinuous when the denominator equals 0. So what will make this expression discontinuous?
X equals 4.
X equals 4. Because we then have 1 over, well, 4 minus 4 equals 0. That's undefined. That means this is discontinuous. You got to be able to spell it. All right. Discontinuous at x equals 4. That means there is a, and we call them this, they're called discontinuities. Okay, so another vocab term. There is a discontinuity at x equals 4. There's a discontinuity at x equals 4. Okay. Any questions there? All right, if you look at page, no, we'll talk about them more tomorrow. All right, we'll be good there. All right. Let's try some of these. Once you guys take a look at, you can either look at number 5 on page 564, example number 1, and kind of read through that and then do question 5, or you can just try your luck right there. Classify it as continuous or discontinuous, and if it's discontinuous, give the values of x that will make it undefined. Okay? Give it a shot there. Work with your groupie. Okay, hey, let's check this out. What did you guys do? Cody?
I plugged in numbers that would make the denominator equal 0.
Okay, so you tried numbers to make the denominator equal 0. Did you find any?
Oh wait, never mind. Take that back. I did not find it.
Jody? No? Nick?
You can't have that because it's when you square a negative, it's always going to be positive.
Okay. So if I set, did anyone try to set the denominator equal to 0? That's what we should be trying to do. All right? Now, rather than guessing and checking, just say, okay, when is x squared plus 1 equal 0? And the answer is, I get a negative there, and then I take the root of that negative, and I get plus minus the root of negative 1, which I think is cool, right? However, that is not a real number. Therefore, no real numbers will make this 0, which means this is continuous. This is continuous because every value I put in for x will give me a solution. Okay? Anytime I put something in for x, I will get a real solution out of that. There's not a single number I can put in there to make that bottom 0. No real number. I could put an imaginary number in, make it 0. Okay, but we're only dealing with our real number system right now. Questions there? Okay, well, let's move on to the next one then. Will anything make that 0? Will you grab that, Cody? Can we factor that? Yeah?
X plus 1, X plus 1.
X plus 1 times x plus 1. Okay? For you?
No, Samantha.
Oh, I thought it might be for you. Who? Sammy?
Yeah.
Sammy, you're out of here. I think. Is she out of here?
Yeah.
Okay. Bring me your assignment really quick, Sammy, so I can show you what to do. Okay. We have x plus 1 over x plus 1 now, or 1 over x plus 1 and x plus 1. What makes those 0? Negative 1. Negative 1 will make this one 0. It'll also make that one 0, so I'd have 1 over 0. This is discontinuous at x equals negative 1. My discontinuity is at x equals negative 1. Now I'm going to keep saying that term, discontinuity, because that's what we have. We have a discontinuity at x equals negative 1. Yes?
So do you want to write it that way or say just
You can just write it like that for now. Okay? Any other questions there? Try that guy right there. 5A, B, and C, and then we're done talking about these today. A, B, C. Give it a go. Go. Everyone, A, continuous, discontinuous.
Discontinuous.
Okay, so it sounds like discontinuous. B,
Continuous.
continuous. C.
Continuous.
Okay, well, let's check. So we're saying x squared minus 16. It says that we could get something that'll make it 0. So if we set it equal, we get x squared equals 4 or 16. Unbelievable. Okay, and x equals plus minus root 16, which is x equals positive negative 4. Now, those of you who remember how to factor, you can just think of x plus 4, x minus 4. Saves a lot of time because then you get positive negative 4 that way. Okay. Either way, this is discontinuous at x equals positive negative 4. That means it has two asymptotes. If we were to graph this, we would have an asymptote that goes down through here at 4 and one that goes down through here at negative 4. Two asymptotes. Okay, now that's going to be important for tomorrow's stuff. All right, we spent 3 days on 8.3 because it's that much fun. The magic of 8.3. Okay, questions on A? All right, 5B, or not to be, or not 5B. Okay, we can stop there, right? Because we're going to take the root of a negative. The root of the negative is imaginary complex. This is continuous. Whoever said continuous, well done.
Thank you.
US. Okay. Hi. Oh, I need collateral. Need collateral. Yeah, you got some collateral. Okay, here we go. X squared plus 2x minus 6. We have x squared plus 2x minus 6 equals 0. Can we factor? No. So what do we do if we can't factor? Quadratic formula. First thing I'm going to do, because if I know the root of the quadratic formula is negative, then I don't have to do the quadratic formula. So we call that root a, what do we call that? The discriminant. Discriminant is b squared minus 4ac. B squared is
4.
4 minus 4 times negative 6. Negative 4 and negative 6 is 24. So 4 minus 24 plus 24 is 28. Okay, so we have to do the quadratic formula. Opposite of b is negative 2 plus minus all over 2. Okay, what's the root of 28 simplified? 2 root 7. Now, those of you are like, whoa, dude, he's like flying. That's because we have done the quadratic formula now. This is the 3rd year. You should know it. We should be able to fly through it. Expect it. Okay, so here, can we factor? Yeah, what can we take out? It's not actually factoring, it's reducing. Take out a 2. 1, negative 1, 1. So we end up with?
Negative 1 plus or minus 1 plus or minus root 7.
Root 7. Good. Those are our discontinuities. Discontinuous at that. Now, if we were actually graphing this, we want to put that in decimal form, because those would be our asymptotes. But for today's sake, we could be fine with that. Questions? Okay, everyone take a look at your 2 assignments that you picked up on the way in. 8.3 and the review. All right. So our first assignment, the 8.3. You're not going to cross anything out on this page because we're taking so many days to have so much fun. 8.3, we're going to do example 1 today, 1 through 9. Notice that's the first third or so of the page. If we do too much on one day, then we'll just have so much fun that we won't be able to handle it. So we only do that much. And then on the mixed side, we're going to do 1 through 6. Okay? So 1 through 9 and 1 through 6. If you're working hard, you will finish that part of it today in class. It is not very difficult. but it's important that you understand. Make sure you're taking good notes. As easy as today's seemed, by the end of chapter 8, today's stuff will seem like ancient history to you, and you'll want to make sure that you can remember it. So have good notes. Second part, this is your review. You have a quiz on Friday. This is to summarize all this new stuff you've learned. So notice, here's 8-1. You should know how to do this. There's 1, 2, 3, 4, 5 problems up here for you to give a shot at. The answers are on the board. Okay, I would do these tonight. Okay, make that a part of your assignment. Tomorrow's assignment is more involved than today's. So don't say, oh, I'll just do it tomorrow. I'll do it Thursday, because 8-3 gets more complex. Do this part tonight when you have time for math. Okay, 8-2. This, anything in italics, they are notes that I'm giving you. These are all notes. Notes that hopefully you have in your notes, but if not, there they are, just for fun. Okay? The rules on graphing. And then on the next page, there's a way to practice 8-2. Practice graphing one, just because you enjoyed it so much last night.
Yeah.
I know everyone did. And then writing an equation given the translations. Okay? I would try to get as much of this part done tonight as I could as well, because tomorrow's, the next page is all 8-3. And when you look at this, you'll be like reading, okay, yeah. Oh, whoa, what's a hole? Okay, why does my graph have holes in it? Okay, it's like your graph has now become Swiss graph. Okay? Like Swiss cheese. Dude, anyone ever, who likes Swiss cheese? Who hates Swiss cheese?
Cheese is life.
Swiss cheese is amazing. Just want you to know. I won't hold it against you if you don't like it. But
should.
okay, so we'll get through 8-1 and 2 tonight. 8-3 is what you'll start on tomorrow. If you want to start here today, you could, but that's up to you. Questions? All right, very good. You have the rest of the class to work. Answers are on the board. Make sure you're asking for help if you need it.